Hello all, welcome to my channel in the subject operations research. In my previous video, I explained how to solve a maximization sum by using simplex method. In this video, I will explain how to solve a minimization sum by using simplex method. So let's start the minimization sum. A minimization sum will look something like this. Solve the following LP. Minimize z is equal to minus 2x1 minus 5x2 subjected to 3x1 plus 2x2 less than or equal to 60. 2x1 plus 8x2 is less than or equal to 70. Minus x1 plus 12x2 is less than or equal to 20. And x1, x2 both are greater than or equal to 0. So if you see this sum and if you compare it with the maximization sum, it's almost similar except the word minimize here, which would be maximize. Okay, so there is no difference in the appearance of the sum. Now this sum can be solved by minimization or can also be solved by maximization. Towards the end of the video, I will explain how to solve this sum by maximization. First, we'll see how to solve the sum by minimization. Our step 1 will be to convert the given sum into standard form. If you have not seen my earlier video to convert the given question into standard form, you can refer the videos. I will put the link in the description. So its standard form will be something like this. Z is equal to minus 2x1 minus 5x2 minimize subjected to 3x1 plus 2x2 plus s1 equal to 60. The second constant 2x1 plus 8x2 is less than or equal to 70 will become 2x1 plus 8x2 plus s2 is equal to 70. And the third constant minus x1 plus 12x2 is less than or equal to 20 will become minus x1 plus 12x2 plus s3 equal to 20. We have two non-negativity restrictions, x1, x2 greater than or equal to 0. And to this, we will also add s1, s2 and s3 greater than or equal to 0. S1, S2 and S3, all these three variables are slack variables, and as they don't contribute anything in the objective function, anything to the objective function, we have written their coefficient as 0, 0 and 0. Okay. After doing this, the next step is to find the initial basic feasible solution. Now to find initial basic feasible solution, we need to identify basic and non-basic variables. I have already made a video to identify basic and non-basic variables. Again, I will put the link in the description. Those who have not watched that video, you can watch it and then come back to this video. The easiest way to identify basic variable is to find whether the variable is appearing in one equation or more than one equation. For example, x1 is appearing in more than one equation, x2 is appearing in more than one equation. So we cannot take them as basic variables, but s1, s2, s3 are appearing in one equation only. So we can consider s1, s2 and s3 as the basic variable. So that x1 and x2 will become non-basic variable, and we can put this non-basic variable x1, x2 equal to 0 so that we will get the value of s1, s2 and s3. So after putting non-basic variable x1 and x2 as 0, we will get s1 is equal to 60, s2 is equal to 70 and s3 is equal to 20. So this is the initial basic feasible solution. After identifying the basic variables, the next step is to put these variables in a simplex table. So a simplex table would look something like this. This is a basic tableau which consists of columns. As there are two decision variables x1, x2, there are two columns x1 and x2. As there are three slack variables, there are three columns s1, s2, s3. Okay, so this is easy. Then how many basic variables are there? 3, s1, s2, s3. So we will put it like this: s1 in first row, s2 in second row, and s3 in the third row. Then we have one column of basis, we have one column of solution, and we have one column of ratio. So we'll see how to fill this entire table. So depending on the number of basic variables, slack variable, surplus variable, artificial variable, the number of columns will increase. This basic variable column will always be there. basis will always be there, solution column will always be there. Next, we have first row, which is CJ row, and we have something written in the CJ row. What are these? These are the coefficients of variables in the objective function. So you can see the coefficient of variables x1, x2, s1, s2, s3 in the objective function, that is -2, -5, 0, 0, 0 are written in the CJ row. Similarly, the basic variables s1, s2, s3 are 0, 0, 0 in the objective function. So that is written here. It is taken from here. Then we have identity matrix. How is identity matrix is formed? In the first row, we have only S1. We do not have S2 and S3. So S1 only. In the second row, we have only S2. So S2 will come here. So the coefficient of S2, that is 1, will come here. Rest will be 0. Similarly, in the third row, we have only one variable, that is S3, and other two are 0. So this will be the identity matrix. Next comes the coefficient matrix. This coefficient matrix is obtained from here. 3, 2 will come in the first row. 2, 8 will come in the second row. -1, 12 will come in the third row. Now it's time for the solution column. And the solution column is obtained from the right hand side of the equations, which were earlier constraints. And that is 60, 70, and 20 in the first, second, and third row respectively. This is the solution column. Now, hereafter, we'll follow these steps. What are the steps? First, we'll find the ZJ value. Then we'll find CJ minus ZJ value. Then we'll find the key column. Key column is one of this column. 1, 2, 3, 4, 5. We have 5 columns. So out of these 5 columns, one of the column will be the key column, and that will be the entering variable. Now in this particular sum, already S1, S2, S3 are in the basic. Okay. So S1, S2, S3 cannot enter the solution because they are already in the solution. So which of the two column can be the key column? Either X1 or X2 can be the key column in this case. So that is the third step from here. Fourth step would be to find the key row. Key row, that is living variable, because if we have found either X1 or X2 as the entering variable, then that entering variable has to replace someone from S1, S2 or S3. So that will be called as living variable. That will be the next step. And the final step would be to find the value of objective function. So we'll find whether the value of objective function is optimum or not. If it is optimum, the iteration will stop. If it is not optimum, we'll continue these 5 steps again. So we'll start first by finding the value of ZJ. Now, how do you find the value of ZJ? ZJ is written here and it can be found this way. This 0 into this 3, as you can see here, plus this 0 into this 2, as you can see here, plus this 0 into this -1, as you can see here. And the answer will be 0, like this. Now, if I want to find the other elements of Z0, that like if I want to find this, then how it will be found? It will be found as this way. Again, this 0 into this 2, this 0 into this 8, this 0 into this 12. So as this is 0, this all ZJ values will be 0. This will be 0, this will be 0, and this will be 0. This is the step to find the value of ZJ. So you can see here to find the value of ZJ. What is the next step here? To find the CJ minus ZJ values. So CJ row is written here at the top. ZJ row is written here. Since all the elements of ZJ row are 0, we will get CJ minus ZJ as CJ row only. -2, -5, 0, 0, and 0. Okay. In the maximization sum, after this step, we will see that either either one of these two value will be positive and that will enter in the solution. But this is the minimization sum. So in minimization sum, the least possible value, that is -5 is the least of these two. These 3 are 0, so we are not concerned with these 3. minus 5 will enter in the solution. So minus 5 will not enter. Minus 5 means what will enter in the solution? X2 will now enter in the solution. So X2 will become the new basic variable. Now since X2 will become the new basic variable, we will have to remove S1, S2, S3, either of them. How will we do that? In order to do that, we will find the ratio. And how do we find the ratio? Ratio is always found as solution column divided by the key column. So here solution column elements are 60, 70 and 20 respectively in the first, second and third row, and key column entries are 2, 8 and 12 in the first, second and third row. So if we divide 60 by 2, we'll get 60 by 2 as 30, 70 by 8 as 8.75 and 20 by 12 as 1.6. Which is the least of this? Least of this is 1.6. So 1.6 will become the key row. 1.6 will become the key row. It means that S3 will, this row, S3 row will become the key row. Now this is key row, this is key column. Intersection of key row and key column is called as key element. So 12 is the key element. Now we have identified that X2 will enter in the solution in the basic. S3 will leave the basic. So here we will write X2. Instead of S3, we will write X2. And what is the importance of this key element? This key element will now be made 1. And the other elements in the key element will be made 0. And I will tell you in a moment why we are doing it like this. Now we can see here that we have an identity matrix 1 0 0 0 1 0 0 0 1, and all the elements here, this S1, S2, S3, these three variables form the identity matrix, and S1, S2, S3 is in the solution. Now we want X2 to come in the solution. Now if we want X2 to come in the solution, we have to make this as the part of identity matrix. So this will become 1, this will become 0, and this will become 0. Now if this is 1, already this is 1. So you can see now S3 will no longer be the solution part of the solution. Basically, S3 will no longer be the basic variable. So this 0, 1, 0, 0 and 1. This will not be 0, 0, 1 hereafter. This will become 0, 0 and 1. So we'll see how it happens. So we have identified now the key row, the key column, the key element, and our next step is to change this to 1. We will make a table here, and in that table we'll change the value of first row R1, second row R2 and third row R3. So that here we'll get 1, instead of 8 we get 0, instead of 2 we get 0. And instead of S3 and its coefficient as 0, we'll write X2, and what is the coefficient of X2 in the objective function? -5. So this will be -5. Okay. Now to make this 12 as 1, we have to divide this entire row by 12. So this will be 12 divided by 12 is equal to 1. So how will we do that? R3 new. So this is called as a new table, and this is called as the old table. So R3 new equal to R3 old divided by 12. So we are dividing the entire R3 old row by 12, such that in this new row we have -1 by 12, 12 by 12 that is equal to 1, 0 by 12 equal to 0, 0 by 12 equal to 0, and 1 by 12 equal to 1 by 12, and this 20 by 12 as it is. Now if you see here, earlier this S3 was basic variable, S3 was in the solution, and this column was 0, 0 and 1. Now this will not be 0, 0, 1, and it will change to something like this. In this case it's 1 by 12. Instead here we will get 1 because X2 is now in the solution. Now to change the elements of row 2, 8 has to be made 0. So how can we make this 8 0? We will make this 8 0 in this way. R2 new, that is this second row, new table will be obtained as this 8 minus 1 into 8. 1 into 8 is 8. 8 minus 8 will become 0. So how I have written here, R2 new equal to R2 old, that is this element 8 minus R3 new. R3 new is 1 into 8. So 8 minus 1 into 8 will get here 0. We'll apply same thing everywhere. So 2 minus 8 into minus 1 by 12 will be 8 by 3. 8 minus 1 into 8 is 0. 0 minus 0 is 0. 1 minus 0 is 1. 0 minus 8 times 1 by 12 is minus 8 by 12. And here we will get 170 by 3. Now we are left with the first row to change, and first row will be changed in this way. R1 new will be equal to R2, this R1 old minus 2 times R3 new. This is this 2 minus 2 into 1. So 2 minus multiplying this entire row by 2. So this will be also be multiplied by 2. So this will become 2. So this 2 minus this 2 will be right 0 here. And we will get the entries like this. And finally the solution. So this is our new table now. This table will take place of this old table, and that will be called as the first iteration. And here these are the entries of the new table which we have replaced by the entries of the old table. Solution. Here we have x2, and what is the value of z now? Z is equal to minus 25 by 3. How we got this value of z is equal to minus 25 by 3? Because S1 is 170 by 3, but S1 is 0 here, so it's of no use. S2 is 170 by 3, but S2 is 0 here, so it is of no use. X2 is equal to 5 by 3. So if I put X2 equal to 5 by 3 here, so I will get 5 5 the 25 by 3, so that is minus 25 by 3. So value of z is minus 25 by 3. So we have completed our basic iteration. Now we are in the first iteration. We'll check whether the value of z that we have obtained is optimal or not. If it is optimal, then our iteration will stop. This is the final answer. And if it is not, then we'll follow the steps again. What are the steps that will follow? To find the value of zj, to find the value of cj minus zj, to find the key column, that is the entering variable, to find the key row, that is leaving variable, and to find the value of objective function. Okay, so we'll start with finding the value of zj. And as I explained in the earlier table, the value of zj will be this 0 into this 19 by 6 will be 0, plus this 0 into 8 by 3 will be 0, plus minus 5 into minus 1 by 12 will get 5 by 12, and so on. How to obtain cj minus zj? Cj row is here, zj row is here. If we subtract, we will get this. Now you can notice here that under x2 we have 0 in the cj minus zj row. Under s1 we have 0 in the cj minus zj row. Under s2 we have 0 in the cj minus zj row. And this x2, s1 and s2 are the basic variables. So whichever is basic variable will always have 0 in the cj minus zj row. So this can also be a check. After solving, if you are getting these 3 as 0, you can understand that what you are doing is correct. Fine. Now, which is the key column? We have two values under in the cj minus zj row. 5 by 12 is positive and minus 29 by 12 is negative. Since this is a minimization sum, so we'll choose minus 29 by 12, and x1 will now enter in the solution. So this column is the key column, and x1 will enter in the solution. Who will leave the solution? That is found from the ratio. How do we get the ratio? Ratio is always found as the solution column divided by the key column. Solution, that is 170 by 3 divided by 19 by 6, we'll get 17.89. Again 170 by 3 divided by 8 by 3, we'll get 21.25. This we have not computed because this is negative. So here we'll get negative and we want only least positive value here, including 0. Which is the minimum of these two? The minimum of these two is 17.89. So this is the key row and S1 will now leave the variable. Who will enter the solution? X1 will enter the solution and S1 will leave the solution, or S1 will leave the basic. And this 19 by 6, which is the intersection of key row and key column, is called as the key element. I have already told you what is the importance of this key element. The key element is important because this will now become the part of the identity matrix. Now you can see we have identity matrix. This, and this. These three which are in the basic form the identity matrix. Now which one will not be the identity matrix? Who is living? S1 is living. So this will now not the identity matrix in the iteration. Okay. So next step is now to make another table. So this is called as new table. This is the old table. And in the new table, S1 will be replaced by X1. And what is the coefficient of X1 in the objective function? -2. So here we'll have -2. And what are the steps to be followed? The steps to be followed are the key element should be made 1 and the other elements in the key column should be made 0. So 19 by 6 can be made 1 like this. Dividing this entire row by 19 by 6. So 19 by 6 divided by 19 by 6 will get 1 here and other elements will change accordingly. Now this 8 by 3 has to be made 0. So how will we make 8 by 3 as 0? Okay, 8 by 3 can be made 0 as R2 old minus 8 by 3 times R1 new will give us the new element of R2 and that will be 0. And similar to make minus 1 by 12 as 0, what will we do? We'll get this 0 as R3 old, that is minus 1 by 12 plus 1 by 12 times of 1. This one is the R1 new element and we'll get the elements like this. Now this is our new table. This is our new table and this will take place of this. This will take place of this. Now see, when I change this, we have X1, X2 and S2 as the elements in basis. So this X1 column, S2 column and X2 column. These three columns will form the identity matrix and S1 is no longer the part of the solution. S1 is no longer the part of the solution and also this will not be the part of identity matrix. Again, we'll repeat the steps. What are the steps? To find Zj, then to find Cj minus Zj, to find key row column, to find key row, and then to find the optimum value. Now, what is the value of Z now? Z can be computed as X1 is equal to 340 by 19, X2 is equal to 60 by 19, and we substitute this value, here we'll get the value of Z. Now Zj values are this, Cj minus Zj values are this, and Z value is 980 by 19. Now if we see, is there any variable which wants to enter in the solution? Yes, we can see here 479 by 608 wants to enter the solution. But since this is a minimization sum and this is a positive value, so this will not enter the solution. We do not have any variable now to enter the solution. Now all the entries under Cj minus Zj are positive. Since we are in the minimization sum, we want this to be positive. As it is a minimization sum, the iteration stops here. We cannot introduce another variable in the solution now. We cannot introduce another variable in the solution now. Iteration will stop. Now there will not be any key column. There is no variable that will now enter the solution. So no entering variable. And it means that we have reached the optimum solution. And since we have reached the optimum solution, Z is equal to 980 by 19 is the final value of Z or final value of objective function. this should be this will come in minus, as this both are minus, this will come in minus. I will explain you in the next slide how this value of z is computed. So this is the given sum. X1 is 340 by 19, X2 is 60 by 19. Where we get this value of X1 and X2 from? X1 in the solution C 340 by 19, X2 in the solution C 60 by 19. We are not interested in the values of slack variables. So we will not write the value of S2. We are not interested in this value because this is not contributing in the objective function. We got X1, X2. Substitute the value of X1 and X2 here. If you substitute the value of X1 and X2 here, you will get Z is equal to minus 51 by 57. That is minus 980 by 19. Z is equal to minus 980 by 19. So this is the final optimum value of Z. So we'll quickly see how will we solve this in a nutshell. So first we'll have a basic table like this. Then we'll write the Cj values from the constraints. Then we'll write the basis values. Then we'll complete the coefficient matrix. Then the identity matrix. Then we'll write the solution elements. Then we'll find Zj. Then we'll find Cj minus Zj. Then the key column here will be the least value, that is minus 5. Then we'll find the ratio, and then the key row. Then this is the key element which will be made 1. How will we make this as 1? For making this as 1, we'll perform operations like this. 3 operations on 3 row in the sequence as explained earlier, and we'll get this new table. So this will be called as iteration 1. Z will be 25 by 3. If I am correct, earlier it should be 25 by 3. Then Zj values, Cj minus Zj values. Again find key column. Again find key row. Again find key element, and make this key column as 1, 0 and 0 by performing the operations R1 new, R2 new and R3 new as we discussed, and we'll get again these values. So this is again iteration 2 matrix, and Z is minus 980 by 19. Can we improve the value further? You can see these are the Zj values, these are the Cj minus Zj values, and we see that this 479 by 608 cannot enter the solution. So all entries under Cj minus Zj are positive. It is a minimization problem, so iteration stops. There is no key column, there is no entering variable. We have reached the optimum solution. We got X1 is equal to 340 by 19, X2 is equal to 60 by 19, and Z is equal to minus 980 by 19 as the optimum value of Z or answer of this LP problem. Now, how will you solve this? By considering a maximization problem. So we will convert it into maximization problem like this. This is the given problem. Convert it into maximization as minimum Z equal to minus of. So this will be converted, this will be multiplied by minus. So I will write Z dash is equal to minus Z, and minus Z means minus of minus 2x1, that is plus 2x1, and minus of minus 5x2, so it will be plus 5x2. Entire remaining things remain the same. What we have changed, instead of minimize, I will say maximize. Instead of Z, I will use another variable. Let us use Z dash, and this will be multiplied by minus 1, and we'll get this. After solving a maximization sum, we will still get X1 is equal to 340 by 19 and X2 is equal to 60 by 19. Because in the entire sum, it doesn't matter whether it is a minimization or maximization sum, we'll get the same value. And Z dash will be equal to 980 by 19. So Z dash will be equal to 980 by 19. for maximization. And if I want to convert into minimization, again back to minimization, what I will write? Minus of z. So minus of 980 by 19. And this will be the value of z. Now, what is the benefit of solving the minimization sum as maximization sum? The benefit is you don't have to remember whether you have to take minimum value, maximum value. In ratio, you have to take minimum ratio or maximum ratio. So when you are solving sums, you may get confused. Always, it's a good practice to convert the given minimization sum into a maximization sum, and then under the Cj minus Zj, we will consider the maximum positive value only to enter in the solution. Or you can, if you are confident enough to remember this minimization case, then you can solve it as I have already explained to you to solve the problem. So we'll stop with this and then